Today we're going to look at simplifying rational exponents. Now, before we begin, we might want to go through and review some of the ones that we did the week before. So there's 12, x to the third, y to the fourth, to the 1/2, and we're going to look at 16, x to the second, y to the third, to the 1/3. So if you want to, you can pause the video and try them, but I'm going to work through these. These are ones that we looked at previously, just kind of making sure we remember how to do them. So pause the video if you'd like to try them on your own first. Alright, so the very first one, an exponent of 1/2 means that you are dealing with a square root. So what we did previously was took everything that's inside our parentheses and just put it right underneath the square root, and then started to break them down. Well, 12 can break down to, let's say, 4 and 3, and then 2 and 2. X to the third means I have 3 x's, and y to the fourth means I have 4 y's. Alright, since our index is 2, that means we're looking for pairs to pull a number or variable out. So I have a pair of 2s, so I can pull out a 2. I have a pair of x's, so I can pull out an x. And I have 2 pairs of y's, so that becomes a y squared. Oops, sorry, I didn't mean to put it as parentheses there. Let me get rid of that. So, leftovers have to stay underneath the square root, so this extra 3 has to stay, and that extra x has to stay. So that would be that one simplified. The second one, since it is raised to a 1/3, it's the same thing as a cube root, which means it's going to have an index of 3. Again, since the top number of this fraction is a 1, we can just put everything in the parentheses underneath the radical. So 16x squared y to the third. Well, 16, let's say 4 and 4, 2 and 2, another 2 and 2, we got 2 x's, and we have 3 y's. So, since this one has an index of 3, we need groups of 3 to pull a number or variable out. So I do have 3 2's, so I can pull out a 2. I don't have enough x's, but I do have enough y's. The part that most students tend to forget is they forget to write their index of 3, because if something doesn't have an index, it's assumed to be a 2. So if you're doing with cube roots, you do have to remember to put that index of 3. Again, leftovers go back under the radical, so the 2, both of those x's, and that's our simplified. So that's what we did previously. We did those types of problems. Alright, so now we're going to start getting into ones where the top number of our rational or fractional exponent is not a 1. So if you need anything from the screen, pause the video. Okay. So let's look at, we're going to look at this one. We're going to look at 2x squared, y to the fifth, to the 2/3. And we're also going to look at a 4x squared, y to the third, to the 2/3. Okay, so what's different about these than the ones we looked at before is the top number of our fractional exponent is no longer a 1. Now, if everything inside your parentheses doesn't have any fractions, there's no negatives in sight, we can go ahead and kind of use the same logic reasoning that we did before. Since this first one, since it does have an index of 3, which again this is going to be a cube root, but because the top number is something other than 1, I can't just take everything inside the parentheses like it is now and put it under the radical. Basically what I end up having to do is that top exponent of 2, I have to multiply that 2 to each of the other exponents in this problem. Now this 2 has an exponent of 1, even though it's not really written there. If a number doesn't have, or a variable doesn't have an exponent, it's assumed to be a 1. So that 2 is now going to be a 2 to the second. The x is now going to be an x to the fourth, and my y is going to be to the 10th. Basically, that top number of the fraction, that 2, I multiplied to each of the exponents inside the parentheses. So now, if I simplify this thing just a tad bit, 2 squared is 4. It's the only thing that I can simplify. Now I can start breaking it down just like we did on the other side. 4 is the same thing as 2 to the 2. X to the fourth means I have 4 x's, and y to the 10th means I have 10 y's. 4, 5. Alright. Well, again, my index in this case is 3. Okay, so again, that means that I need groups of 3 to pull a number or variable out. So I don't have enough 2's. I do have enough x's. And I have 1, 2, 3 y, so y to the third. Got to remember my index. I have 2 2's that have to go underneath, so that'll go back to a 4. I have an extra x, and I have an extra y. The second one is the same kind of idea. I don't see any negatives anywhere out. I have no fractional exponents inside the parentheses, so in this one there's nothing else that I can do. I can just go ahead and rewrite it into a cube root. But I have to remember that top exponent, that 2 in this case, is going to multiply to all those exponents underneath. That 4 does have an exponent of 1, so that's going to become a 4 to the second, an x to the fourth, and a y to the sixth. So if I simplify just a little bit, 4 squared is 16, and now I can start breaking everything down. 16 can break down into 4 and 4. Let's see, x to the fourth means I have 4 x's. Y to the sixth means I have 6 y's. Alright, so again I need groups of 3 to pull numbers or variables out. So I can pull out, in this case I can pull out a 2, I can pull out an x, and I can pull out 2 sets of y's, so y squared. Left over I have an extra 2 and an extra x. Now, honestly though, most of the time, I mean, you could see one like this on your exam. Be honest though, most of the time you're going to have negative exponents or even negative fractional exponents on the outer part. So I'm going to clear the screen, so if you need anything from the screen, go ahead and pause the video. Alright, the general rule is if it has any negatives, and if it has any negatives or fractions, in the parentheses, okay, it's actually going to be easier to use your exponent rules. Okay. So if you see any sort of negatives anywhere, or if you already have fractions underneath or inside the parentheses, it's going to be easier to use your exponent rules, like what you learned in Math 1. So, for example, in Math 1, if you had something like 2x squared y to the third, I don't know, I'm just going to pick something and say 2. We had to go through and multiply that to every single exponent in here, so that'd be a 2 to the second, we'd have an x to the fourth, and a y to the sixth, to kind of go through and simplify. So similar to what we were doing earlier when we were taking that top number and multiplying it to each of the exponents. So we're going to be doing the same kind of thing. So if you need anything from this screen, go ahead and get it. We're going to do a couple examples of those. So the first one we're going to look at is an 8x squared y to the 1/3 to the 2/3. Okay, so as you can see with this problem, I don't have any negatives in there, but I have a fraction inside the parentheses. I'm not going to want to try to write this into radical form, because I'm going to have a radical inside of a radical, which is a royal pain in the butt to try to simplify. So this one's actually going to be easier if we do our exponent rules, which just means that I'm going to take this fractional exponent, 2/3, and I'm going to multiply it to each of the other exponents. Often with these you're going to get fractions, and that's okay. So 8 really had an exponent of 1, so this is going to be an 8 to the 2/3. 2 times 2/3 is 4/3. And you can use your calculator to get those, it's fine. Oops, that's supposed to be an x, I'm sorry. Let me change that. And then 1/3 times 2/3, which is 2/9. And that's okay, you can leave them in proper fractions. The only thing that often simplifies with these, or at least with the Math 2, what they want you to simplify is this right here. If you were to type in an 8 to the 2/3, with the 2/3 being an exponent, it actually will simplify to a nice pretty number. And I know you may or may not have one at home that can do that for you. But 8 to the 2/3 is actually a 4. So the final answer for this would be x, or 4x to the 4/3 and y to the 2/9. And that's how they would leave it on the exam. Where they get that 8 to the 2/3, and I'll show you how to simplify that by hand, because I don't know if you have a calculator at home or not that'll do that. What happens is 8 can actually be written as 2 to the 3rd, and then what happens is when I multiply these two, I get 6 divided by 3, and 6 divided by 3 is 2, so that's why this becomes a 4. But if you're comfortable with that, you can do them by hand. You can also use your calculator as well if needed to be. Alright, so I'm going to look at another example. You just pause. I'm just going to go through examples. Pause as needed when you're looking at these. So let's say a 4, x to the 1/2, it's supposed to be 1/2, y to the -2 to the -1/2. Alright, again, I see some fractions in there, I see some negatives. I'm definitely going to want to use my exponent rules to simplify this. So, again, I'm going to multiply this -1/2 to each of those exponents in that problem. So this is going to be a 4 to the -1/2. This is going to be an x to the -1/4. And this is going to be a y to the 1st. Okay. Alright, now back to a rule from Math 1, if you remember. Anytime that you have a negative exponent in a problem, you have to go ahead and move your exponent. So anything that has a negative exponent is going to have to move to the bottom of the fraction. And when you do that, you get rid of the negative. So, I'll change the color on this real quick. So this one right here and this one right here. Those two are both going to end up having to move to the bottom of the fraction. And when we do that, we got to get rid of the fraction. And this y to the 1st is going to stay at the top. Again, like I mentioned on the last problem, usually the only thing that's still going to simplify, change colors again, is this number right here. Once you're done, it will usually simplify in the final answer. 4 to the 1/2 is a 2, so that would be your final answer for this type of problem. Okay, so we're going to look at probably 2, 3 more. So again, pause the video as needed. Alright, so let's say I have 4x to the -4, y to the -1/2, oops, to the 3/2. So again, I see some negatives, I see some fractional exponents in the parentheses. I'm definitely going to want to use my exponent rules. So this is going to come out to a 4 to the 3/2, because that 4 really had an exponent of 1. 1 times 3/2 is 3/2. X to the, this would be -7/2, and a y to the -3/4. Again, I see some negative exponents, so anything with a negative exponent has to move to the bottom, and when it does, I get rid of the negative. So both of my variables move to the bottom, get rid of the negative. And the 4 to the 3/2 is going to stay at the top. Well, the only thing that I have left to do to be able to simplify this is that very top. That 4 to the 3/2 will actually simplify, and that becomes, in this case, an 8. There's my answer. Okay, the only other type of problem that you're going to run into, at least in Math 2, is honestly, just like these ones we've been looking at, that's probably what you're going to see in your exam, or at least it has been that way for the past 3 years or so. I'm going to look at one other example. So, I also see these on the exam sometimes too. So, let's say x to the 1/2 over x to the -1/3. I'm going to do a y to the, I don't know, 5/2, and y to the 1/2, let's say. Okay, so what you do with these is you're going to combine the x's together and the y's together to kind of get kind of a simpler form. Now, what you can do is if they have the same base, like these two have the same base, they both have a base x, what you do is you're going to subtract the exponents. And you can subtract them by hand. Most people just type these things in their calculator, which I'm going to do right now. So this one I'm going to do 1/2 minus a negative 1/3. So when I do that, I get a 5/6, so this x is going to be to a 5/6. And you want to do the same thing with your y values. We're going to go through and subtract those exponents. Again, most students just put it in their calculator, so 5/2 minus 1/2, which is just going to be a 2. Okay. Now, if you were to have any of these that have a negative exponent, let's say this was an x to the 5/6 and y to the negative 2, then that y to the second would have moved to the bottom. But in this case, they're both positive, so that would be my final answer. With the homework for this one on Canvas, what I did was I ended up putting them as multiple choice. I think I put 3 options in there. So just got to make sure that you can simplify those things down and make sure that you can find your answer.